I'm Jamie Alac. Thanks very much for coming to the 25th anniversary for Abel. Who I have here is Brendan Bellomo. Brendan is an award-winning writer, producer, and director and visual effects supervisor. Brendan actually won the Student Academy Award for Bohemibot. Is that how you pronounce it? Yeah. Brendan's obviously a visual effects supervisor. He's overseen and executed over 2,000 visual effects shots. Some projects include The Wire, Beasts of the Southern Wild, and The Blacklist. In addition to this, and while we have Brendan here today, he's actually directed and created many demo reels with the Phantom 2K and Flex 4K cameras. And he's been an integral part of the launch of both cameras. And I think that's when we first met you, right? It was probably about 4 years ago, I think it was, when we did
I think we started in 2010.
2010, yeah, so 4.5 years, yeah. Currently, Brendan's actually developing a robotic motion control system, which is to move like cameras, lights, sets even, which is kind of amazing, at rapid speed. So obviously this works in conjunction with the high-speed cameras. So that's actually what Brendan is here today to talk to us about. So thank you, and over to you, Brendan.
Great. Thanks so much, Jamie. Just wanted to say thanks to everybody at Abel and Mo and Andy, and I really appreciate you guys letting me come in and talk. And it's been great working with everybody with the Phantom camera launches. And I've got 4 different projects kind of showing a whole range of things that we've been able to do with the Flex 2K and Flex 4K systems. And I think I'll show each one and then talk about it a little bit, see if you guys have any questions. And the main thing to talk about here today is the combination of completely practical effects and doing things all in camera, and then combining that with really cutting-edge visual effects, compositing and CGI. And I think it's such an interesting space today in the current filmmaking vocabulary when we combine these things from really old pieces of cinematic language, being able to do miniatures and practical effects and smoke and mirrors and all these things that get our imagination going and are totally timeless, and then bring that together with what's happening in Nuke or Maya with facial motion capture or particle simulation, and these things that, you know, maybe 5 years from now might even look a bit dated, but we might look back to something from, a movie in the 1950s and still say, wow, this holds up, or something in 2001 with the fluid effects. So I'm really interested in bringing these things together and kind of want to demonstrate how we have been doing that. And the first piece we have is something where we need to do a title sequence for a semi-permanent festival down in Australia. And this is something people would normally do in CG, and instead we bought 300 pounds of chalk dust and exploded it. So I'll show you the first clip and then talk about it a little bit more. Oh, can we turn the light off as well? Thank you. Can we show that, pause it and just show that beginning section one more time, and I'll just talk through some of what we did. Great. So this is with MK12, who's a studio that did the opening titles for films like Quantum of Solace. And they came to me saying, oh, we want to have this exploding alphabet. And they didn't want to do it in After Effects, they wanted something totally real. And so I worked with Renegade Effects Group to design a system to make letters that would detonate on cue. So we built a mold for each letter and packed them with special chalk, and then filmed it with Phantom 2K at 2,500 frames a second. And it's lit with just a cluster of 2K airy lamps. It's a really simple lighting setup, but because the frame rate is so incredibly fast and we're really, really stopped down, we get just beautiful results. And the trick to doing something like this is a lot of testing. And the Flex allows us to have such quick feedback and playback instantly that we can make all these great adjustments with it. And I just love that aspect of the system. It's just a beautiful imager. So we built a lot of air baffles and special air pumps that would then fill these chambers with very, very high pressure air, and then we'd blast that into these little letter molds with holes in the bottom, and that would shoot all the dust up, and we'd film that with the camera. And for this is before I'll show you later in the clips of some of the robotic stuff we're doing. So there was no focus pulling system, and this is me racking focus for exploding dust that moves, I don't know how many feet per second, but it was very difficult. So it's all focus pulling by eye on a Nikon lens. So some ACs can appreciate that challenge. So I want to show you guys a couple other clips. Gregory Wilson and I had a long relationship with Abel and Vision Research and Tony Lucatordo over there, and we've been working on these launch films for the Phantom cameras. And the next piece I'd like to show you is what we did for the Flex 4K system. And we got together with the fire department out in Connecticut and basically filmed real firefighters and all real fire. And there's no CG in what you're going to see. There is a lot of compositing, but everything is real, and it's all filmed with the Flex 4K. So I'll show you guys that piece, and we'll talk about it a little bit. You just pause it there. Thanks. So you can maybe cycle back and I'll talk through the material a little bit. You can just pause it there and I'll talk about this sequence a little bit. Perfect. So this scene has no effects in it at all. This is all done completely in camera. And we studied a lot of movies and a lot of references of photography of fire and all sorts of different subjects, and wanted to kind of capture it like this wild animal almost. And I wanted to see this interaction of fire and water at this almost microscopic level. And so we worked with the fire department to basically set up a fuel oil fire and burn this shelf, and then we just hit it with a fire hose, full water pressure, and we filmed this in the middle of the night and had only one take to do it. So we filmed the shot with 2 Flex 4K prototypes. It still had, I think, duct tape on the bodies at that point. And Greg Wilson was the DP on this and did a really incredible job. And so the firefighters were just watching this again and again on our OLED monitor on set, and they said, we've been looking at fire for 20 years. We've never seen it like this. So a lot of people online actually thought this was CG, and it was very weird, but it's not. So if you can actually roll the tape back to the first shot, we'll talk a little bit about this living room composite. So most people would say, hey, let's do this in RealFlow, or let's do some particle simulation. And I think it's so much more interesting to have real physical, practical effects. So you can stop right there for a second. So this scene is actually Greg's living room in Brooklyn. And we decided to just do this as cheaply as possible, got a bunch of lighter fluid and just lit it on fire and shot it with a Phantom. This is actually all done in Nuke X, and this is probably 60-layer composite that takes about 24 hours to render on a 12-core machine with 64 gigs of RAM. So you guys can imagine the complexity there. We filmed all this fire. It's all propane that we shot against black. And then we set up the Phantom in the living room with absolutely nothing in it except the furniture and no lights and just a little bit of fog. And we put it on a motion control slider, basically like what you would use for time lapse. And we did this just lateral camera move going through it. And that was one pass. And then we put lights on the ground, just wrapped in different colored gels, orange gels, to get all this reflection on the floor. So none of this is done in the computer. It's actually another pass that we shot in sync with the camera moving across the scene. And that allowed us to basically say, anytime we composite a flame in, it will activate that layer of light reflecting on the ground, and it gives us this hyper realism, and it actually saves a lot of time, it saves a lot of money, and it looks better in post. And then all of the debris and everything, it's all real. I shot real embers, and the falling debris that you see between those two windows up at the top of frame is wood that we burned in the bathroom, dropped into the bathtub. So very low-tech way of getting pretty high-tech stuff. And I think a lot of people look at these techniques and they think about high-speed cameras and they say, oh, sports, or you could do something for a science fiction movie, but they are just universally applicable to storytelling, because I think it allows us to see the world in such an emotional way, because we can subdivide these moments in time. And there's even pieces of performance that we can look at that are so compelling at high speed. So I think it's really not just for effects or seeing something from another world, but seeing our world in a different way. And when I get to some of the robot stuff later, talk a little bit more about that. But yeah, do you guys have any questions so far?
You said you shot it with 2K lights, some of those close-ups of the dust.
Yes.
Do you have problems with pulsing?
Excellent question. So I had done a lot of research about different Flickr issues, and I've found that with anything less than a 2K, there can be major Flickr problems. But with these specific lamps, there's just airy 2K open faces, I didn't have any Flickr issues at all. And it was just something that I tested, and I knew because I'd tested it already that it was gonna work. So I've heard that it's a little hit and miss down there. Generally, like I think 5Ks, 10Ks are really safe. And when I have the budget, it's all T12s and bigger. So that's kind of the rule of thumb. But sometimes you can do a 2K. Yeah, so let's move on to the next part.
Is there an extract of 4K?
Yes, this is a 1080p down convert of the 4K master. So I think we may make the 4K version accessible online at some point. It's pretty incredibly sharp. And we actually, when I've been shooting with the Flex 4K cameras, the guys at Vision, Feroz Dalal, our tech who we work with there. Oh, can you pause it for a second? Has been kind enough to take out the anti-aliasing filters. So I've actually found that that's totally unnecessary and looks pretty incredible. Okay, so this goes backwards in time a little bit in terms of technology to the Flex 2K, but it's a great camera because we can do 2,500 frames a second with it. So there was a feature that I VFX supervised, and they needed someone getting sucked into a galaxy, into another dimension, but they had like no money. And I was like, okay, well that's gonna be like $50,000 to do that with particle simulation. And they're like, well, we can't afford that. So went down to the art store and figured out that we could do something similar using an old CD case. You guys remember those CD drums you'd like bulk CDs in, burn all your music for your friends? Yeah, that's out a little bit. Switch with you. How's that? Much better. So this is a fish tank and a CD case and some acrylic paint, and I'll show you what we made with it and talk a little bit more about the technique. You can play the clip, that'd be great. So this is 2,500 frames a second. And that's just the raw footage out of camera. And then here's a composite that I did in about 15 minutes, just stacking those two layers together. You can pause it right there. Perfect. So one of the things I realized about particle simulation, having dealt with it for many years, is when you're doing that at the computer, you're looking at like days just to set stuff up, and then days or weeks, whatever it is, to render it. And each shot, you're in for $5,000 a shot or $20,000 a shot. Very expensive render time. It's the worst. But if you're working with fluid tanks, you can get a bunch of cheap paint and water and fish pumps. And if you have a phantom camera, which is of course very expensive, amazing piece of equipment, you can produce something like 80 or 90 of these in 2 days. So we were able to shoot just that many different galaxies, storms, clusters of spirals and different pieces of debris flying around in liquids at different frame rates. And it's a whole beautiful library of things, and they're incredibly organic. And they work so beautifully, and you can change the light and everything. So that's been an amazing technique for years, and people have used this on Close Encounters of the Third Kind with the ship there, and end sequences of Raiders of the Lost Ark. There's so many things that have great fluid tank work. But one of the issues that's kind of plagued it for years is because you're usually shooting high speed, you can't move the camera. So it's hard to get a lot of perspective shift. This is a great application for it, because with a Galaxy, your spaceship isn't really fast enough to move around and see the galaxy with a lot of perspective transformation. But new thing that we've been working on developing is being able to incorporate camera movement with these super high frame rate miniatures by using robots. So a couple of people have been doing stuff like this. The guys at the Marmalade are into it, and there's a lot of applications for it for commercials. But for me, I'm much more interested in the storytelling aspects of that and actually combining it with actors and with miniature sets. And we've been doing a lot of experiments with that. So I think, looking forwards, everybody's saying, oh, software in the box. And if you look back at the techniques that we've used for so many years, there's just incredible ways to do things that if you combine them with the newest technologies like the flex cameras or Nuke, which is what I use to composite these couple of layers together, just give it a little three-dimensionality, you have something that's totally timeless, and it's actually a lot more cost effective. Any questions on this segment? Okay. This is lit with, I think, again, my favorite 2K systems. This is just in a garage in a fish tank, and so this whole galaxy is about 6 or 8 inches wide, and it's lit from about 2 feet away with 2K open face. So that just does it. And then there's a lot of negative fill, and of course there's black up top, and then we're really, really stopped down, and then at just over 2,000 frames a second.
Have you tried anything where you might have lit it from underneath? In other words, that the fluid is translucent or so on, so that you could get light coming out rather than lighting it? You want to affect it like that?
Yeah, we have, and that works great too. It's just all a question of what you want to achieve and how many rigs you can do and how many takes you can do. But yeah, that looks beautiful as well.
In that 2,000 frames, do you have a problem with the flickering?
No, we didn't have any flicker problems, and again, that's something that you have to test. And if you want to be really safe, I would go with 5Ks and larger. The 2K is right on the limit. Sometimes it's perfect. Sometimes there's issues. It's just something that you have to be very careful with. Cool. Well, we'll go to the final section of this stuff and the next part in the video. This is a little behind the scenes material from these robots, which we have taken from auto manufacturing surplus. They used to build cars for Mercedes, and now we're mounting the Phantom Flex cameras onto them. So this is our first day on set with the cameras, and we're able to do pretty incredible movement with them. And the strange thing about these versus even a traditional motion control system is that they're really, really fast. They have much higher weight capacities, and we can actually combine many different moves even into one take. So one aspect of this project was a music video, another is kind of an art film. And we were able to get, I think, 192 slates in a day and a half. So it's very efficient. We can do a lateral dolly, we can do a push-in, we can do a close-up, a wide shot, crane move, all within the span of a few seconds. So that's some of the behind-the-scenes stuff. And then the next section of the clip will show you some of our research and development tests and look development from our work in progress. This isn't out yet. I'm actually in the middle of post on it right now, and we're doing more shooting tomorrow with the robots. So very much a work in progress, but I wanted to show you guys some of the newest stuff and then have a bit of a conversation about it. So we'll play the last section. Thanks. So if you can roll it back and play that section again, I'll talk through a little bit about what we did to accomplish this stuff. So in some regards, we could consider all this to be CGI or computer-generated imagery, but it's really not. What we're actually doing is using robots to move a phantom camera, shooting at 1,000 frames a second, very quickly around, like in these cases, an actor's head. So for a shot like this, perfect, go ahead and play there. I'll come back to this stuff later. Okay, so this is what's called a point cloud. And just pause it there for a second. Perfect. This is a cluster of distance samples derived from all the different perspectives you get when you take a phantom and you move it in a semicircle around someone's head. So just in the same way that your eyes look at a person, and if you cover one eye, you have a pretty good idea of what things are looking like, but if you open up your other eye, you can tell a little more, and if you start moving around and shaking your head back and forth, you can start to see really the whole shape of an object. So parallax gives us that definition, and in that regard, every one of these points is really just a different way of capturing information. So it's a truly three-dimensional camera. And if we were to think about this as a stereoscopic camera, instead of having just 2 views and gathering three-dimensional information, we're gathering in a shot like this about 1,000 views. It takes about a second to go around the head. So it's very, very detailed, and that allows us to get this model. With that, we then take the light that's falling on the actor and we map it back onto those points, and we can come up with this very ethereal thing. And the kind of compelling aspect of this is that we could take this and we could do a very photorealistic human, or we could do something much more artsy like this. And I'll let you play forwards and talk about some other aspects of it. Thanks. So this is all composited in Nuke, and for instance here, this is all using real bokeh samples, meaning that the out-of-focus elements here, say for the lasers, are sampled really from real camera defocus. So everything in visual effects is moving towards sampling things from real cameras, real footage, and I think, you know, as powerful as particle simulation systems are, everything should really be done in camera. So this is the same technique here, and the system that we're working on now, which we're shooting with this week, is actually going to allow us to be able to make these point clouds completely moving and animated. And we'll be capturing using many mirrors for each frame and having people actually singing or talking or moving around. Yeah, so we'll have the lights up for a second. Yeah, I don't know, do you guys have any questions about it?
Did you talk about the first couple shots?
Yeah, definitely. Can we actually roll back to the beginning of that? And I'll talk a bit about those first 2 silhouetted shots. So this project is kind of dealing with the meeting point between very realistic things and very abstracted things, and kind of seeing how that plays around. And part of that is this sequence that we shot. So there's no CG in this at all. This is all actually done in camera and then just composited back together, essentially as just some fancy double exposures. So this is footage of this band that we worked with for the music video, flinging themselves backwards, lit by about 50,000 watts of tungsten light, while being hit with 2 fire engines, each with a 1,000-gallon tank with deck guns and hoses, and just launching themselves back onto this grassy field where they're getting just blasted with water. And then we're shooting that at 4K with Zeiss Summicron lenses on a Phantom Flex. So 1,000 frames a second. So it's kind of the most elaborate way you could possibly do something that a lot of people would just say, let's make a little layer in After Effects and, going to have this Instagram look on it. But I think the level of nuance that you can get with that is pretty magical. So I much prefer something like this where it's not a particle system, it's all real, and you're going to create something that'll be a lot more timeless because of that. And I think the great thing about the Phantom cameras is they allow you to merge different worlds together so easily because you can capture so much information. They're so clean. The color is so beautiful. You have all this res and all this color fidelity that it allows you to just push it much harder in post, especially a lot harder than if you had something that was compressed. So I think that's still very, very relevant, actually.
Have you shot with plasma lights at all?
I haven't, but I'd love to. It sounds exciting.
They rock.
They rock? Okay.
Great. Solid.
Cool.
Could you elaborate a little bit more about what a point cloud is?
Yeah, for sure. Could you play forwards a bit? Okay, so this shot, let's see. I might have you pause on the next one. And fast forward a bit to the next part. Okay, right there, perfect. So point cloud is something that is just a whole bunch of dots in 3D space that are all on the surface of something. So you could make a point cloud of a building or a person, and it basically looks like a constellation of stars, except their layout in 3D space exactly represents the shape of something or somebody. And they make kind of these beautiful three-dimensional sculptures of people's heads. So the way that we create them is we take a phantom and we put it on a robot. And you guys remember those green screen shots from before where the cameras are whipping around those guys' heads. We shoot at 1,000 frames a second, and we have somebody hold very still, and the camera moves around them and captures every different perspective of their face. And then we load that into the computer, and we essentially run it through a 3D tracking system, which uses the difference in perspective between those to calculate the depth of each point, and ultimately the position of that point in a 3D volume. And then we can take the footage itself and how it's lit. Like if we have a little light here on the nose or some backlight or a little catch on the eyes, and we project that luminance back onto the points themselves. And this gives us an approximation of the real person. And interestingly, if we could imagine increasing the density of these points to a place where they would fill in the black gaps between them, we would have all the three-dimensional position and all the original luminosity of every point. But then you start to say, oh, well, what about specularity and reflection? You know, if I'm looking at his face from here, I might have a little glare on his eyeball or a little, shiny point on his nose where he's a little bit sweaty, and then I move around to the side and that goes away. Well, the interesting thing about this type of capture is we actually have all that information because we've taken 1,000 pictures of the head from all these different perspectives. So what we're working towards doing is mapping that all back into this point system and having a photorealistic way to capture these sorts of things. And for me, nothing is ever going to take the place of an actor. It's not about that. It's about finding new ways to look at the world, different ways to make art and sculptures and visual effects and tell stories. So it's not about that. Like, this isn't a different type of motion capture, and it's very similar to that technology, but it's real, and it's real imagery, and we're using phantom cameras to just gather more information about space and about time, and that's what makes it a powerful storytelling tool.
And the capture is just visible light, is not infrared or anything?
Yeah, it's just visible light at this point, and we're not using any time of flight cameras, which are these lasers that kind of like those laser tape measures you get at the hardware store, just measure the distance and the time it takes light to go somewhere. So this is all done just purely image-based. Yeah.
With the light that you had going over their faces, is that like a projection input, or was that also created from the cloud?
Oh yeah, great question. That's just about the lines on the faces sequence. That stuff is using the points, like we'd see here, to create a 3D model of the head, which is just a wireframe. And then we use that almost as a virtual mannequin onto which we can project essentially footage of lasers. And so because we're using the phantoms and we're getting all of these point information, we can do things in post where we actually have the three-dimensional information of someone's head, and I can project light onto them. So say we were doing, you were working on a sequence like in 2001 where there's that slide projector projecting the light up onto his face in the pod. You know, that's a very similar type of thing, and you could do it practically, or you could do it in post, but very much in an image-based way that's extremely realistic, and you use the real model. So this saves a lot of time doing modeling, and you get just a lot of interesting nuances that you wouldn't have if you're just sitting there modeling it.
So you actually shot lasers and after?
Those lasers are actually done in CG right now, but we have a lot of other laser footage that from our library and other things that we're shooting that we're going to map on there. But those ones are done as an effect in Nuke.
If you did this old school,
Yeah.
like projecting those laser images on the person's face and shooting the two simultaneously, then you'd have synchronization problems with the flicker rates on the various elements, or?
No, that would actually work just fine. I mean, lasers are constant light, so we wouldn't have any flicker issues. Might blind the actors, but other than that, it should work.
And like also the opening shots where you had the layering the double images, you could theoretically just have a mirrored glass in front of them and reflecting an actor behind the camera.
Absolutely. No, it goes all back, you know, even to techniques that are used in, you know, Metropolis and, you know, shift and process and all that sort of thing. So, you know, yes, a lot of this could be done with glass in camera, but then you don't have the flexibility of editing it. So I like something that's kind of, you know, if you're creating everything from scratch and you're in Maya and you're in After Effects and you're generating all that, you have to think of everything. You have to tell the computer to make imperfections. It takes forever. It's painstaking. If you're shooting something with a phantom, everybody has that moment where, you know, you blow something up or you do something beautiful with an athlete and you have that, wow, this is incredible. I didn't even know this thing happened. You're never going to get that in a computer. But if you take that and you combine it with the flexibility of multi-layer compositing, three-dimensional imagery, then you have the best of both worlds. You have something that's incredibly nuanced and magical with things that will surprise you every time you do a shoot, and the ability to edit and change time and get rid of things or add things back in. So I think it's the nexus of these two aspects of filmmaking that give us some of the best storytelling opportunities these days. And you know, that's what a lot of folks have been doing with things like Gravity, where it's like, okay, we're going to have real humans, we're going to put them on these different robotic arms, illuminate them with real light, and then we'll do a lot of CG for the background. So it's a very, it's an interesting and empowering time for sure.
What about combining elements that you've captured at different frame rates, or even projected things at different frame rates?
Yeah, all very possible and intriguing to do for sure. And I think there's a lot of, you know, there's certainly storytelling potential with it. There's a lot of technical advantages, you know, in terms of being able to manage strobing or combine different explosion elements that are shot at different scales. You know, let's say you have some smoke that's done at a half scale model and that looks good, but then you have some exploding element that's, you know, a 10th scale model shot at a different frame rate. Very easy to composite. Usually very hard to do camera movement, but with robotic motion control, we can actually do the same move at different scales and at different speeds with the same precision. So if you need to do a dolly move for a miniature, you might move through a 1 foot space, you know, for 1,000 frame a second shot, and you'll do it, you know, really quickly. And then if you do that same move on a live action set for somebody running through the shot that you just want to be 250 frames a second, you could do it a bit slower, but the robotic arms have about a 10-foot reach. So that move would, you know, if it translates up to 10 feet, then you can cycle through that. So yeah, there's a pretty endless possibilities because ultimately it's just things to capture time and space and move stuff around.
What was the software you used to make the point cloud? Is that proprietary?
No, it's not. It's called Nuke, and it's what's used by ILM and Digital Domain and Pixar. It's pretty much the industry standard for visual effects and compositing. It's all the Avengers movies, pretty much everything. Yeah, it's a yeah. You could do it for home use.
I think we're going to have to wrap it up there. We've got another presentation happening. But thank you very much, Brendan.
Thank you guys
amazing
so much.
presentation. Just note, this reel is actually playing in the other theatre. And Brendan's going to be around, so if you want to ask him any more questions, he'll be around here. Yeah, but in Theatre 2, in the Sony Theatre, this reel is playing. Thank you, guys.